peach flavored water. What you know about that? Okay, so this is the third and final free fall video that I'm gonna do. So I feel like after you guys get through this video, you should be able to do these problems on your own. So let's see what the problem looks like. Here we go. So it says an object dropped on Mars falls 64 meters in 4 seconds. Find the acceleration due to gravity on Mars. So as always, we start with our diagram. And it says an object, so I'm going to draw an egg. And an egg is on Mars, and it gets dropped 64 meters. And the time that it takes to drop is 4 seconds. Delta x is 64 meters. And let's start with our assumptions. First assumption is we're going to set x initial equal to 0. And the second assumption is that our initial velocity equals 0 meters per second. And that's because we assume that the egg started from rest. In other words, we were holding it and we let it go, but at the instant we let it go, the initial velocity is still 0. So let's add those over here. And our unknown. What's our unknown? It says find the acceleration due to gravity on Mars. So our unknown is acceleration due to gravity on Mars. Okay. And now we got to pick our equation. And I'm just going to stick with this one, because this one's worked out pretty well so far. So why not give it another go? So the equation is delta x equals x initial plus velocity initial times time plus 1/2 at squared. Just like the other problems, x initial is 0. Velocity initial is 0 times time. Anything times 0 is also 0. And so delta x equals 1/2 at squared. And so we're trying to get a by itself. And the first thing we need to do is get rid of this 1/2. We do that by multiplying both sides by 2. Cancels out that 2. Cancels out that 2. This 1 doesn't matter anymore. So we have 2 delta x equals at squared. Alright, still need to get a by itself, so let's divide both sides by t squared. And these t's cancel each other out. So now we got a by itself. And so we have a equals 2 times delta x over t squared. And let's plug in our numerical values. So a equals 2 times 64 meters over t squared. And t is 4 seconds. So 4 squared seconds. Okay. So acceleration equals 2 times 64, which is 128 meters, over 4 squared seconds. So that's 16 seconds squared. Alright, 128 divided by 16. Now we got to solve it. I'm going to punch that into my calculator. 128 divided by 16 equals 8. So acceleration equals 8 meters per second squared on Mars. That's the acceleration due to gravity. That kind of makes sense because the acceleration due to gravity on Earth is 10 meters per second squared, and Earth is bigger than Mars, so it has more mass and therefore more gravity. But that's our final answer. Let's check and make sure it's correct. So again, I pulled this off of some random website. Here it is. Here's the problem. 8 meters per second squared. So once again, we got the correct answer. Alright, adios.